Hello everyone, good afternoon. Hope you're all doing well. Just gonna give us a couple of seconds and then we shall start today's webinar Wednesday. Grab yourself a drink, grab yourself a snack of some kind. If you're working alone with this open in the background, appreciate it all the same. Wishing you the best of luck with your work, and we'll get stuck into this in just a moment. Apologies for any drinking sounds you heard. Okay. So, let us get into today's webinar. Welcome to Testing and Testing with Artificial Intelligence for our webinar Wednesday. My name is Benjamin Taylor and I work with Go Bigger. Hope you're really excited for today's webinar. Hello, Sabrina in the chat. You're really excited for today's webinar, and AI is a hot button topic, so really excited to see everyone here for it. So without much further ado, let's actually discuss what this webinar includes. Namely, I want to talk about why we need to look at AI testing in general, as this webinar is sort of broken up into two topics of looking at AI testing and then looking at how we test with AIs. So as our first topic, looking at AI testing. Looking at examining why we need to look at AI testing, which will follow into how do we test with AIs. So how do we use AIs in sort of the testing space and the testing pipeline? Following that, we look at how we test AIs. This is a very similar question to how do we test with, but they're very distinct. How do we test AIs looks at more so of AIs as the actual project that we're developing and how do we test those compared to how do we bring in AIs into the testing space. And then finally, just wanted to have a little brief mention and talk about the ISTQB Certified Tester AI qualification, as that's sort of what this webinar is sort of structured around, but I have included a lot more information than just what's there, a couple of some extras. So with that said, let's get into today's first topic. Why do we need to look at AI testing? Well, isn't it not obvious? Because AI is already everywhere around us. Because AI is becoming a larger and larger part of our daily lives. It is everywhere, from music recommendations to we use it for assistance at work. We use it to help us write our LinkedIn posts or maybe our emails. AI is here, and like it or not, AI is seemingly here to stay. So let's try and be smart about how we're using it. Because a good question that can come from AI is, how do we know if we're actually using it correctly? Not in the sense that this is what the developers intended us to use the AI for, but how do we know that the AI is used correctly? How do we know that it is telling us what we need to know in the right way? Which brings us to a bigger question of, how do we even test AI systems in the first place? They're all-knowing magic boxes, so how do we test those and how do we get good tests out of them? And can we even confirm that what the AI is doing is like actually correct, or do we just have to guess and sort of hope? Well, let's dive into a couple of these questions that I'm not going to be going all the way into, but just to discuss them a bit further and get you thinking about how much reliance we put on AIs and how we can test our own AIs. So before that though, I want to have a quick discussion about the kinds of AIs that we're talking about, because there are many kinds of AIs. And so I'm going to stick with sort of the most basic three main types, and then we'll dive further into different kinds of one specific type. So the first AI type that we have is the narrow AI. Narrow AIs perform tasks in a sort of limited context, and they're really good on that specific task. Before 2019 or so, this used to be what people thought of when they talked about AIs. This is your basic artificial intelligence in like basic chatbots or game computers kind of deal. This is also what's used for like classification systems. They're very good at their own specific tasks, but you wouldn't ask them to do something outside of those tasks, as they just would have absolutely no clue. So there's your narrow AIs. Then, in 2019 and onwards, we were introduced to general AIs. General AIs are touted to possess some level of cognitive abilities and some ability to reason. How much reasoning ability, how much cognitive ability they have, it's still sort of to be determined. It's still being worked on right now. Some people would have you believe that their AIs can indeed think and properly reason, but they'll still fail some basic kind of tests. But this is where we find ourselves currently, and this is primarily where we have a lot of our large language models and from natural language processing. So we have things like ChatGPT and Claude and OpenAI, these kinds of large general AIs that are good with almost any task, but maybe not perfect at them. And then we have our super AIs. Super AIs we don't need to worry about yet, and hopefully never. But this is super AIs is sort of when we get to Skynet levels of AI, of it knows everything, it can track us everywhere kind of deal, where we're not going to worry about super AIs just yet. And if any tech billionaires are looking to make their own super AIs, I have a couple of movies that I might suggest watching first. But we're going to focus primarily right now on just general AIs, as that is the sort of key point as it stands right now. So what technologies do we use in AIs, and what are they sort of based on? It's a fairly common question that we may have about AIs, is that how are they actually made, or how do they actually work? And so they work in a couple of different ways, and as a sort of non-exhaustive look into how they can work, well, perhaps they work with some sort of fuzzy logic, where the AI will make decisions on how it should act or how it should react based on some sort of ambiguity that it's been given. Maybe it won't always choose the same thing 100% of the time, so it's that sort of fuzzy logic of how it works. Maybe we're looking at some reasoning techniques that the AI has. Perhaps it's based on deductive, inductive, or abductive reasoning. Deductive meaning that it can work top-down, so it knows for our known premises and can sort of identify information at a lower level based on how it knows it works. Inductive, where it makes sort of observations on the bottom level and makes guesses on how the top layer works. As well as abductive, in which it has incomplete observations and it needs to try and draw conclusions from those. So these AIs can work in different ways, and depending on sort of where we're targeting the AI to, that can be useful to identify. We also have a common thing where people think AI, which is machine learning. And this includes neural networks, where they used to be normally for image recognition, but also now natural language processing. This is where we get our large language models, or LLMs, from. These are neural networks where it sort of simulates the next steps, or tries to understand from a somewhat human perspective of how things work, at least if we look at neural networks as a brain, although that analogy isn't quite right, let's say, but as a general idea, we can say that. There's also linear regression, which is looking at dependent and independent variables that we observe and manipulate to see what the outcomes are. Linear regression is used commonly in systems like stock market predictions, looking at medical risks of patients, looking at sales forecasting, those kinds of areas where it's easy to sort of see outcomes from that and sort of map them back into this giant multi-dimensional sort of a graph kind of deal, or scatter plot. So those are the kinds of some technologies and ideas AI is based on. But how do we normally look at defining AI's quality? Because that's a key issue when we talk about AIs and software in general. We want to make sure that they're high quality. And we have to look at it in a slightly different way than compared to standard software. Ideally, if we want to talk about AI's quality, we need to talk about how flexible they are. So this is, can we put the AI in different circumstances, in different situations to see how it reacts? For example, ChatGPT it probably wasn't trained to be a medical assistant. So how well can we use it if we are treating it as a medical assistant? Is it up to date with its medical knowledge and identifying body parts, muscle groups, that kind of thing? Maybe, maybe not, but that's part of flexibility. And then we need to talk about evolution. So how can the system improve itself? Or can it improve itself even? Is it able to synthesize new information in a meaningful way? Does that information extend to all of the AI and its future sessions, or is it just locked to that specific session? So can the AI evolve over time? One quality characteristic we don't want to see is any bias. This is if we look at the outputs that the AI produces and what we expect, is it fair? Does it provide no favoritism towards specific groups? A common situation that used to happen with AIs and potentially still does is taking the example of a hiring AI that looks at CVs. Pretty sure we all know stories of those AIs looking at CVs, and if you are male and have a white European sounding name, you're more likely to be hired compared to other demographics. So there's some inherent biases that were present in those kinds of AIs that maybe they didn't quite see until they hit production and entered the real world, which is concerning and definitely a failure on the tester's parts there. But maybe our AI doesn't have any bias, but it does have reward hacking, or some existence of that. Reward hacking is where the AI sort of achieves its goal in a sort of novel manner outside of our intended methods of how it should be solved. Either it'll think about hacking the system in the first place to sort of get the result at once, or maybe it'll avoid some intended action we want it to actually follow. As an example of reward hacking, let's say we're developing a investment AI. I'll tell you what's smart to invest in. The investment AI may realize that, hey, when I pump a stock an absolute ton, its value goes up dramatically, and then I can short it. And so the investment AI will just tell you, actually, it's very simple to get a good return. Just give this one stock like $10 million. It's going to be highly valued, and then you can sell it for cheap, which is technically correct, but it's probably not the kind of behavior that we're expecting. So we sort of need to limit that, and that's an example of reward hacking that we want to avoid. And lastly, when we talk about quality, we also need to talk about safety, because a lot of AI systems actually interact with us directly. Namely, we want AI systems to not cause harm to anyone, to people, properties, or the environment in general. And this can be quite complex, actually, as a sort of quality characteristic, depending on if the AI is deterministic or probabilistic, if it has self-learning, as well as some other quality measures we'll discuss later. So these are really sort of tough questions on how we define AI's qualities. But now that we've discussed that and why we think AIs are important, really important to look at during testing, let's talk about where and how we can test with AIs. Namely, I want to look at where AIs can be used in testing. So looking at the sort of standard procedure of how testing is performed, let's see where AIs can actually assist us. So first up, we have the test planning stage. And indeed, I think AI can be useful in test planning. Test planning normally involves looking at test objectives and test approaches that we can involve in this sort of stage of testing. And I think the AI, if we give it a good sort of summary of our problem and situation, I think it could, looking at large language models primarily, I think it could be quite helpful in sort of identifying these areas. At least as a sort of a second voice to this. I think that's where AI is really good, as a sort of second voice, as a colleague to confer with, not to just blindly trust. Then the next stage of testing is, of course, test monitoring and control, of which I don't think the AI is really good here. The test monitoring and control needs a sort of human element to see how everything's going and progressing. And whilst we could use AIs and sort of pipe some outputs from testing progress into the AI and how that's going, I think it's probably better to stick with a more human element in that case. But then we can look at test analysis, and I think test analysis is another area in which we could use AIs. Test analysis includes identifying testable features and conditions in our tests. And I think the AI, even if we only just give it a general information on what's happening in the project, it will give us some testable features and conditions on how we can test and where we can put our testing efforts. This comes in then to our test design, which I think is another area in which, the AI can probably assist us, because it's very test design is where we look at sort of test data requirements and how we need to format our data and what data we need to collect. So I think AI is pretty good and it's quite useful here. But where AI really takes off is in test implementation. Namely, this is the creation of testware. This is creating not only our test scripts and suites, but also our testing data. I think that's a key area in which AI excels. And it's useful that it really excels here, because then we have test execution, where we run our tests, and well, I don't think the AI is really good at running our tests, as well as test reporting, in which we probably want them to be maybe not manually made, but we probably don't want AIs to construct test reports for us in a sort of general sense, especially if we're showing them to stakeholders or project leaders or the like. So where does AI excel at being used in software testing? I would say primarily when we're looking at creation of realistic data, following some kind of schemas or the like. Do note that, good practice, you will probably still need to sanitize your test data, as you can't trust the AI 100% of the time that it's going to follow that schema, and it's going to be valid in the first place, so you will still need to sanitize it and check it. But it is pretty good at generating some test data for us, depending on the system we're testing, of course. I think AI also has a place looking at test objectives, and it's also really good at assisting us in finding out those test objectives or requirements and sort of identifying where we can test. But, and very important, but I would say these should still require some expertise knowledge in order to help choose the right goals that we're actually searching for. So we can use AI, definitely, but I think we shouldn't be 100% reliant on it. AI should not be a test manager by any stretch, but it can help us sort of identify some aspects that maybe we weren't thinking of prior. So that's how we test with AIs, and now how do we test AIs themselves? Well, if we want to test AIs, then we should remember something. That no matter what, AI is software. At the end of the day, AI is software, and as we know as being testers, all software can be tested. Unfortunately, though, AIs are quite different, so how we test them is also quite different. And if we're looking at some AIs with non-deterministic or probabilistic sort of values, then knowing those answers ahead of time isn't always a certainty. Isn't always certain what kind of answers we're going to get out and whether these are good answers. This means that if we can't know how we test them, testing is quite difficult, it means that white box test techniques are sort of impossible to employ. We don't understand the neural networks of how AIs work. We don't understand how the tokenization of large language model works. Maybe at a conceptual level, but to trace it, no way, can't do that. And because we're looking at non-deterministic or probabilistic models, normally means black box techniques are quite difficult as well. So how do we test AIs then? If we can't use white box techniques, we can't use black box, are we just stuck with exploratory testing? Not quite. Because a good way to look at AI testing is we can say that AI testing is done when AI tests are good enough. If the AI is working good enough, then we can say, yeah, we'll ship it and we're happy with how it's going. Good enough is a difficult sort of thing to quantify, but we can say good enough is when the AI sort of meets our expectations in testing. And how do we quantify that? Well, by having confusion matrices. So we look at the different results that the AI should have come up with, and we compare it to what it actually came up with for our test cases and sort of see if it's matched accordingly. If it has a high percentage of matches, if we're willing to ignore some type 1 or type 2 errors, if they occur, then perhaps we can say that the AI is good enough. If we're looking at neural networks, then how about coverage measures? How about ensuring that each node has a certain activation rate and each node was activated to that degree? So that way you can sort of hopefully have faith that the AI isn't hiding some sort of secret, unseen behavior behind one of its nodes. In fact, you can be fairly confident that the nodes are all working as intended and are well utilized. Plus, we can also look and test our AIs for conceptual drift, where over time, the idea of what the AI does or what it should perform like changes without us really interfering and changing that. So we need to test to make sure that the AI is sort of stable in that sense. And then from that, a good question rises. So if we have these sort of expectations, that's well good and all, but what about the actual answers and outputs we give? No, it gives us. And how do we check that an AI has the right answer? Well, if we want to check that it has the right answer, then we probably just use the same methods as normal, which in testing, we use test oracles. Test oracles, of course, detail the expected results from our tests. They ensure that our tests follow a sort of procedure and the output is what we expect. The problem becomes, with our test oracles, however, is when we look in non-deterministic systems. Because non-determinism means that, well, we're not getting just one answer, we're getting sort of a multitude. And for that reason, how do we know if an answer is good enough? Or, as we call it, correctness. How do we know when an answer is correct? To which there are a couple solutions, and there are no sort of easy ones. But a common solution may actually be just use an AI as a test oracle itself. Which does have its own issues, though, so it's not a foolproof way. But it is something that we can mitigate. Because we may be wondering, well, how do we know if an AI is correct? We won't always understand if an AI managed to get the exact same responses that we're looking for. Is it someone's job to sit next to the AI and see its outputs and say, yep, that matches up as expected, or what should we do? Well, normally, when we're using an AI as an oracle, it's normally because it's met our prior expectations. This is a system that we've already examined, we've already tested and found, yep, this is good enough for our services, but we want to make it better. So the oracle can actually just be the previous version of a system that we're testing ourselves. So if we perform better, wonderful. If it performs worse, that's okay. We still have the original system. Or to try and combat some biases that may have been in our training data or in how we implemented it, we could always have an oracle be a trusted third-party system with an entirely different architecture. Maybe they don't even perform, the oracle doesn't even perform the same task as our new AI that we want. But the oracle can still process what our new AI outputs and is able to get some results from that. Because AIs are efficient, they are fast-paced. So I think that the only thing that can really compete against AIs is AI itself. I think using a AI test oracle can actually be a really great idea, depending on our system. Because if we have our oracle and we have our expectations, Then we can look at performing A/B testing. We'll perform some small changes to our system to have our B and original A, and we can run all of our test data once more to sort of see what the output is. If our B performs better and it improves results, then perfect. We have our improvement. We have our next iteration of the AI that we can either further train to improve its results further, or we can ship it and prepare it for delivery into the production environment, where it will replace the current AI if there is one. But how do we test AIs? Because we know test oracles, that's getting the right answer. Sure, but as testers, we know that getting the right answer is only half of testing. Because what about other aspects of software quality? Because we've talked about a couple already, but AI has more quality characteristics, and these include the adaptability of the system. So, to what ease can the system be modified for new situations? And this normally means physical restraints. Does it require specific CPUs or GPUs in order to train with? If not, then how do we adjust that to make it so we can train it on nearly anything? What kind of autonomy does our AI have? And this sort of is dependent on the autonomy we actually want from the system itself. Because if we're looking at a self-driving car, then we probably want some degree of autonomy there. Generally high degree, but we still wanted to release control to the actual driver at some points in some sort of dangerous situations. But maybe if we're looking at a recommendation or a classification system, then we want complete autonomy. We don't want the user to have to look at the recommendations and be, which one do you think is best for you? No, we want the system to automatically suggest that. How annoying would that be if Spotify asked you every 3 songs, what do you think about this next song? No, we want it to be completely autonomous. We then have the triple threat of transparency, interpretability, and explainability. So transparency of how obvious is the training data, so where is our training data source from, and what algorithm is used to make the AI, because that is important, so we all can understand how the AI was trained in the first place. Namely, if something comes out about the technology, algorithm, or training data that we use to make the AI, then we can follow up that and fix it. Interpretability of how we understand AI that is going to be used by stakeholders and users. So how is it going to be used by them? Does that sort of meet the software quality that we're expecting? As well as explainability. This is a really key one, especially if we're talking about like classification systems or linear regression, where how can we describe and explain how the AI came up with its results? Because if we can't quite explain how the AI got there, then maybe that means we don't understand either. Maybe the AI understands something we don't, or maybe the AI has no clue either and it's just making something up. We need to be able to properly explain that aspect. Then, of course, we also have ethical concerns too, and those are part of software quality. Ethics meaning, how does the AI impact our lives? Ideally, it should have a fairly positive impact in its overall use and for its use cases. Ethical quality often includes transparency, but also security, safety, as well as respecting laws and human rights. So those are definitely parts of software quality that we need to be paying attention when we look at how we test AIs. And that brings me to the ISTQB Certified Tester AI qualification, which is a certification aimed at anyone looking to test AI-based systems or use AI in your testing endeavors. I've gone over a couple of good topics already, sort of briefly throughout this webinar, but it includes more such as introductions to AIs, looking at quality characteristics of AIs, as well as it goes into great detail on machine learning in regards to data preparation and validation, and how we can test our AI-based systems and much, much more. And as a little bonus, we've already been covering this today in this little webinar, so you're already a little bit familiar with how we can test AIs and this qualification. But there's plenty more that I haven't covered in this area. So I do encourage you to go out and get your qualification and become a certified AI tester, because AI is a growing field, so why not go ahead and stand out with your own qualification. And that brings us to the end of today's webinar. So if you do have a question, please feel free to put it in the chat. More than happy to answer. And as we wait for questions to come in, if you enjoyed the webinar and you're not already following us on LinkedIn, then why not go ahead and follow us there and subscribe to our YouTube channel. We keep up to date. We keep you up to date with everything that's going on with Go Bigger, as well as if we're doing any hirings or if we have new courses. Check it out on LinkedIn. You'll keep up to date there. Plus, I see a question from Zabrana. I'll get to you. That's a good question. Plus, if you're interested in learning with us, then why not go ahead and check out our shop to see what courses and qualifications we have currently available. Right now, we have one for the Robot Framework Certified Professional certification. It is a lifetime cert, so why not go ahead, check it out, and if you think it's right for you, would love to see you in a workshop. Plus, if you want to stay up to date with us even more than just on LinkedIn itself, why not subscribe to our monthly newsletter at Grow Bigger, where you can keep up to date with everything that happens at Go Bigger on a month-to-month basis. You can see what upcoming webinar topics we have. You can keep up to date with the software testing world in terms of events or news. And we promise to only email you once a month, and you can always unsubscribe if you don't like it. So you have nothing to lose. Why not check it out? So whilst we're here, I just want to address Zabrana's question. Do you expect testers to be replaced anytime soon? I would say no. At this point in time, I don't see testers being replaced. I think AI has its uses, definitely. I think AI can potentially help us in some phases of testing, like say component or component integration. Perhaps if we feed it that information, but we can't always feed it those informations. It could be restricted. It could be confidential, so we don't pass that to an AI itself. Maybe it can, I think it has a role in the future of assisting testers in sort of key areas, maybe to help them identify how they should perform tests. But I think a lot of it is still going to fall to testers themselves. And remember, AI is a tool, so we still need to learn how to use it. And we still need our own knowledge to use it effectively. So I don't think we're going to be replaced anytime soon by AI. I don't think that's a real concern that we have right now. As always, there's always going to be people who panic about it, and there's people who are going to fully embrace it. But I expect people who fully embrace it will, or maybe they are already feeling the little issues that AI does have. So I think right now and for the foreseeable future, we as testers are perfectly fine. But we definitely should think about learning to adapt with AI as part of testing. At least right now. We shall see where time takes us. Oh, good, happy to clarify. And that brings us to the end of today's webinar, looking at testing with and testing of AI. I hope you enjoyed, and I hope you're looking forward to next week's webinar as well. We're just going to put next week's webinar live on our LinkedIn shortly, in which we're going to be examining exploratory testing and how we can actually perform it. So, if you haven't conducted exploratory testing yourself and you're a little intrigued, why not check us out? Stay up to date with everything on LinkedIn, give us a like, give us a comment, it really means so much to us. Have yourselves a wonderful week, and we're looking forward to seeing you next week for Webinar Wednesdays. Until then,